Hello everyone, I welcome you all for the lecture series videos of Mechatronics and Automation. I am Dr. J.Yokesh, Assistant Professor of Mechanical Engineering, and here I am going to discuss about the PID controller. So in the previous video, we have discussed about the proportional controller, integral controller, and derivative controller alone, and the combination of proportional integral controller and proportional derivative controller. Here, PID stands for the combined mode, that is proportional integral derivative. So we have these modes which are combined in a single controller, which is called a PID controller, that is proportional integral derivative controller. So we'll discuss about the mathematical equation formation about this controller, and followed by the controller output response and few applications of the PID controller in the upcoming videos. So in the PID controller, as I told you earlier, we are combining all the three modes, namely proportional, integral, and derivative, which gives the equation that is written, that is illustrated in the slide. The controller output is the function of the summation of proportional mode output and integral mode output and the derivative mode output, which is equal to KPE, where KP is the KPE plus KI integral of 0 to T E dt plus KD dE by dt, where KP is the proportional constant and E is the error, and K is the integral constant and dt is the change of time, and Kd is the derivative constant, and dE by dt is the rate of change of error or change of error with respect to the time period. The controller output is equal to KPES plus 1 by S KIES plus SKDS. So the transfer function can be derived KPE plus 1 by SKI plus SKD, which is equal to KP of 1 plus 1 by T1S plus TDS, where TI is the transfer function of integral mode and TD is the transfer function of derivative mode. And this is the mathematical equation. Now, this is the circuit diagram which explains how these three modes are combined and which is parallelly accessing. So here we are combining these three modes parallelly, which will not affect the output of any one of the mode. So here we have an comparator which compares the error signal. We have a system which produces output response, maybe a temperature or maybe a flow or velocity, whatever it may be. So initially we have a set point value which is combined by means of a feedback signal. The comparator compares the error signal and gives the error signal to the three modes. So each mode is having distinct characteristics, and the output of these three modes are collected by means of adder. The function of adder is to combine all the outputs and which produces output signal which is proportional to the uh, error signal received by the, which is the summation of the error signal received by the integral controller, proportional controller, and the derivative controller. Finally, the process of the system is uh, controlled, that is proportional to the summation of the error signal received by the adder. And once it is controls the function and the feedback signal, again it is sent into the comparator. Then comparator compiles all the data and it compares the set point value, and the cycle is repeatedly monitored by the signal. And this is the PID circuit where we have an uh, resistor of derivative resistor and followed by the integral resistor and proportional resistor, which are all combined together and which produces the output signal. And these are all the references for my presentation. Mechatronics, authored by W. Bolton, published by Pearson Education, second edition in the year of 1999. And the second reference is Mechatronics, authored by Bradley, published by Chapman and Hall, the year of 1993. So in this video, we have discussed about how these three modes are combined, which we are having PID mode, proportional integrative derivative mode, mathematical equation for this mode, followed by the output response. So I hope this video is useful to you. Thank you for watching this video.